This section examines independent suspension. One of the main benefits claimed for independent suspension is that unsprung mass can be kept low. Also, if a wheel on one side hits a road irregularity, it won't upset the wheel on the other side on the same axle. And it allows wheel camber to be adjusted individually when provided for by the manufacturer. One of the simplest and most common independent suspension systems is the MacPherson strut type. It can be used on the front and rear of the vehicle. It consists of a spring and shock absorber unit called a strut. The lower end of the strut is located by a ball joint fitted to the end of the suspension control arm. Its upper end is located in a molded rubber mounting. If the unit is on the front, the upper mounting includes a bearing to allow the complete strut to rotate with the steering. A tension rod or stay bar extends from the body subframe to the outer end of the control arm. This maintains the location of the control arm during braking and accelerating. In this front-wheel drive suspension, the control arm is a wishbone shape with two widely spaced mounting points. This prevents backward and forward movement, so a tension rod is not needed. Wishbones can also be used in a parallel link system. They can be used in pairs with the coil spring between the lower wishbone and the suspension crossmember. Alternatively, the upper link may be a wishbone with a coil spring mounted above, combined with a single pivot lower link located by a tension rod. On some vehicles, a torsion bar provides the springing medium. The torsion bar is attached at the inner fulcrum point of the wishbone, or control arm. As the suspension is deflected, it twists around its center. It can be fitted to the upper or the lower link, depending on the type of vehicle. The upper link is shorter than the lower one, irrespective of the springing method used. When the suspension is deflected, the unequal lengths allow the track of the vehicle to be maintained near constant, but with some changes to camber angle. Generally, when the car leans during cornering, the inner wheel leans outwards at the top, and the outer wheel leans inwards. This helps to maintain maximum tire contact with the road surface.